Welcome to module 10 of database management systems. We have been discussing about intermediate level features in SQL, and this is the second and closing module on that. So, we have in the last module talked about join expressions, views and transaction a bit. In this module, we will try to learn SQL expressions that are responsible for maintaining the integrity of the database. We have talked about integrity a little. We will now see how explicitly integrity can be checked and how different kinds of integrity can be ensured through SQL. We will also talk about more data types. We have seen the basic primitive data types, and we had promised that we will talk more about the data types, including user defined data types here. And finally, we will talk about a very important aspect of authorization as to who can do what in a database through SQL. So, this is the module outline. We start with the integrity constraints. Integrity constraints guard against accidental damage to the database. That is, there are certain real world facts that must be ensured in the database all the time. For example, in bank accounts, we have a minimum balance that need to be maintained. For a particular customer, we might want that the customer's phone number must be present. We may have certain age bar in terms of entering into certain memberships or certain employment and so on. All these kinds of real world constraints need to be represented and maintained in the database, and that is the purpose of the integrity constraint. And if we will first look at the issues of integrity constraint for a single relation, and we have seen the use of not null and primary key. We will also talk about what is unique, and we will see how actually general constraints can be checked in terms of a check clause with a predicate P. So, not null, we had seen this before. We can while creating the database table, create table, we can specify a field to be not null, and then in that case null values will not be allowed in those fields. So, there must be some value given. You can say one or more attributes to be unique. If you specify them to be unique, that means that in any instance of the table in future, there cannot be two tuples which match in all of those attributes. So, if we say A1 to AM are unique, that means that if we have two different tuples in the table any time in future, two different rows in the table T1 and T2, then across A1, A2, AM, they must differ in at least one attribute value. So, uniqueness is a basic requirement for being a candidate key, but they are still permitted to be null, which in contrast to what is true for primary key. You already know that primary key values cannot be null, but uniqueness allows null values, but they have to be different. The check clause is where you say check and then you put a predicate. So, the idea is like this. Suppose I know that I have specified an attribute called semester. It is a varchar 6, which means that it can have a string maximum of length 6, but naturally I can write anything there. I can write morning in that field. I can write welcome in that field and so on, but those are not valid names of semesters. So, I want that in my design semester must have any of these values only. So, we say semester in. So, I have listed the values that are allowed. In is the set membership. So, it says that the semester in. So, which means that the value of the semester has to be one of these four, and this whole thing now becomes the predicate P, on which I do a check, which means that whenever I am creating, once we have created the table, when I want to insert or update the values in the table, the records in the table, then the value of semester has to be always within this, otherwise the check integrity constraint will fail and the update or insert will not happen and an exception will be raised. This is the basic idea of check constraints. Now, let us move on to a more involved integrity check which goes beyond one table. So, let us suppose that we are talking about the instructor table. We have the instructor table, and instructor table has a department name. Similarly, we have a department table which naturally has a department name. Now, we know that this is the key in the department table, and therefore, here it is a foreign key. Now, while we are inserting records in the instructor table, how do we guarantee that the record that we insert has a corresponding entry in the foreign key table, that is reference table? So, it is when we are inserting and in a faculty, in the saying that the faculty belongs to biology department, there needs to be a biology entry in the department table as well. So, this is known as referential integrity, that is, once you refer from one table to the other, that reference must also be a valid one, otherwise all your computations will go wrong. So, this is for saying it formally. If there are two relations and one relation has a primary key which is used in the other relation as a foreign key, then there is a referential integrity that needs to be maintained. So, here we are just showing the effect of that. So, we have created a table. This is the first one is what you have seen earlier, creating the table course, and that table course needs the name of the department. So, we are specifying that it references the department table. Now, if it references the department table, it must ensure the referential integrity. So, this just says that this refers to the department table, but I can be more specific to say what will happen if the integrity gets violated. For example, I have created this, and the course table has an entry which has a department name, say biology. Naturally, biology department should have the entry, there should be an entry in the department table with this department name biology for this to be valid. Now, say for some reason the biology department is abolished, and that particular record from the department table is removed. Naturally, the course which is referring to biology in terms of its department name, that particular record will become invalid. So, we can say that on delete what you should be doing. One most common action that we specify in referential integrity is cascade, that if the referred entity is deleted, then the referring entity should also be deleted. So, if you delete the biology entry from the department table, then all courses which have biology through references to department as their field value should also get deleted. Similar thing can be there on update also. For example, biology department say tomorrow changes the name to bioscience. Now, if I have an referential integrity put on the course table as on update cascade, then as I change the bioscience, the name to bioscience, all records in the table course which had the department name as biology will necessarily get updated. So, this is the way to maintain referential integrity. Cascading is one of the most common way to handle this, but there could be other ways to take action also. There could be no action, that you say okay, I do not care, let that happen. In that case, some because of the violation there could be some exceptions thrown, or you can say that if this happens, then I will set that field to null, or I will set that field to some default value and so on. So, this is how the referential integrity has to be handled. There could be integrity violation during transactions also. This is an example of a self-referential table which of persons, where every person's entry needs the name of the mother and the father, which are also entries in this table. So, necessarily if you are entering a personal record, you need these fields to be populated, and that can be populated only if those records already exist. So, there is some order in which you have to enter the records, or you have to set them as null and then update them in future, and or some ways to say that, well, do not check this integrity now, we will talk about this integrity at a later point of time. So, these are the issues that necessarily will have to be addressed. Let us move on and look at the SQL data types and schemas. So, in addition to the data types like char, varchar, int and all that, you have an explicit date data type, which gives you a year, month, date kind of format with a 4-digit year, because date is very frequently required. You have a time type to give you hour, minute, second time format. You have a time stamp, which is date and time together, and you have what is known as interval, where you can do a date or time difference between two different dates, two different time, two different time stamps and so on. So, these are the common added built-in types, which makes it very easy to handle the temporal aspects in SQL queries. In addition, the next that you can do is you can create an index. So, let us look at this. So, this create table definition you understand well by now. I can do this, I can say create index and give a name for the index and specify which field on which the index should be created. So, here we are saying that the index should happen here. This is the name of the relation, this is the name of the attribute, name of the field. Now, this does not change any data, neither does it change any schema, but it creates certain additional structures, so that it becomes easier to search this particular table using IDs. So, if I have a query like this, that I am trying to find out all information about a particular student, then as we have said that by default the different entries, the rows of a relation are unordered. So, the only way to find out this particular row, and in fact, whether it actually exists, would be to go over all the relations one by one. But if we index it, then it creates some kind of a efficient data structure through which it can be searched out very efficiently, very easily. With a later module we will talk about indexing, but just to give you the idea that this is similar to finding out a value in an unordered array, if you are thinking of C. In contrast, I can we all know that this can be done, but takes a whole lot of time, it takes order and time, but I could keep those numbers in terms of a say some binary search tree, balanced binary search tree like red black tree or 2 3 4 tree kind of, where the search can be conducted in a log n time, or I could keep it in terms of some efficient hashing mechanism, where the search could happen in terms of an order one time also. So, indexing has a lot of importance, and we will talk about that more, but this is how you create index in SQL. You can have user defined types, you can say create type and use some specific subtypes of a type as and give it a name. So, it is a numeric 12(2). So, which is a 12-digit number with 2 decimal places of precision, you can call it dollar and then use that as a type name. So, type name doing this helps in two ways. It makes sure that wherever you actually have to conceptually refer to dollars, you are talking about dollars. So, it is easier to understand, and you are making sure that everywhere the same numeric precision is used. You can also actually go further and create domains, which is very similar to create type, but domains are more powerful in the sense that in a domain you can also add constraints like not null, and you say that this is person name. So, you say that this once you have said that this person name is 20 character long and it cannot be null, then you do not specifically have to every time you define a field based on this domain type, you do not have to specifically say that it is not null. You could also create specific constraints in terms of the check clause and make it easier. So, now if you say degree level, you do not have to put check clause explicitly in the SQL query, because it is already specified in the created domain. SQL supports certain large objects which are either called blobs if they are binary, or called clob if they are character objects. The major difference in terms of the large object types are they are not stored as a part of the table, they are stored elsewhere, and you actually maintain a kind of a reference, a pointer to that large object. So, this is very useful in terms of handling photos, videos, and big binary files, character files also. Let us move to authorization next. Authorization is the process by which you restrict different users to be able to do different kind of operations. You would recall in the early modules on database overview, we mentioned that there could be several types of users for a database. There could be absolutely application users who necessarily do not feature as a part of the database development, but there could be application developers, expectedly most of you would become application developers. There could be intermediate higher level of analysts who design databases, design constraints, decide on indexes and so on, and there could be database administrators. And also in terms of different application programs and programmers, there is a need to separate out who can access which part of the database. For example, if you look at a banking system, then while I am my net banking application is accessing different information about my account, one part I need to ensure that I can only access my account, and also what the database system needs to ensure is that a net banking application should in no way be able to access the information about the specific employees, because in the same database the information about the bank employees will also be there. It should not be possible possible to access the information about different physical information about the branches as to where how many square feet of area that branch has and so on and so forth. So, we need to put variety of restrictions, and as we will see that authorization or this process of restricting or allowing different access and different authority to operate is decided based on two different factors. One is what you want to do, and two is who wants to do that. So, what and who. So, we identify different operations or different operations on certain tables or operations on certain attributes as what needs to be done. And on the other side, we will identify who in terms of specific individual user IDs or groups of user IDs or roles that exist. So, here we will just try to show you how we can do that in SQL. So, the first part of the authorization is being able to do different things with the database, that means the instances of the database. So, there are authorizations to read, insert, update and delete. So, read is where you can access the data, but you cannot modify. Insert is when you can add new data, but you do not, with insert rights authorization, you cannot update an existing data, you can only insert data. You can have update rights where you can change, make modifications, but you may not be, you are not allowed to delete data, and you can, there could be a delete right where it allows you to delete data. And mind you, these authorizations are not, these are all independent authorizations. So, you may have, I mean certain authorizations may need certain other authorizations to be present. For example, if you are updating, naturally you will need to read, but it is these are all independent authorizations, and you may have one or more of them to be able to do the appropriate actions. Similar set of another set of authorizations will exist if you want to, for those who want to modify the database schema. Naturally, this is primarily for the applications and application programmers, and this primarily would be for the analysts, that you can index a different table, you can you can have authorization for resources, which mean you can create new relations, create new schemas, you can alter schemas, you can drop schemas and so on. So, these are the different kinds of authorizations that are possible. So, let us see how it works. The authorization is specified in terms of a statement called grant. So, you grant an authorization to a privilege list and on certain relation to a group of users. So, grant what kind of authorization you are granting, that is the privilege list, on what relation on view you are granting, that is the on condition, and to whom are you granting those. So, user list could be a specific user ID, or you could say public, which in this case everybody will have that, or this could be a role, which we will see what a role is. Granting a privilege on a view does not imply granting any privileges on the underlying relation. Please mind this this one, because you have seen that a view can be formed from multiple different relations. So, if somebody has been granted a particular privilege, say read privilege on a view, then it does not mean that the corresponding underlying relation, say you have been granted a read privilege on faculty relation that faculty view that we did, that does not mean that the user will automatically get a read privilege on the underlying instructor relation. So, that has to be kept in mind. The grantor of the privilege must already hold the privilege, that is, you cannot grant. Naturally, grant will be done also by somebody in some of the users, it may be. So, that user who is granting must also have the privilege, same privilege on the specific item. So, you cannot grant privilege on something, some relation or view on which you yourself do not have that, or it has to be the database administrator who naturally has privilege for everything. The privileges on SQL, there is a select privilege, which is so this is a privilege list. The select privilege, which basically means read access. So, it is saying select privilege as read access on instructor, and these are the different users. So, this is how typically you can have insert, to ability to insert tuples, the update privilege, this should be easy to understand now, delete privilege. So, only thing is read is called select here. So, these are the different privileges that you have in SQL, and you have one all encompassing privilege, which is called all privileges. So, that is a short form of allowing all these allowable privileges. Certainly, if you can grant an authorization, there needs to be a reverse process, that is, if you want to withdraw authorization of certain privileges on certain items for certain users. So, that is known as the revoke statement. So, you can revoke it, the structure looks exactly similar to the grant. So, you revoke a privilege list, select, insert this kind of on certain relation and view from a set of users. So, you can say that revoke select on branch from this. So, once this is done, then U1, U2 and U3 will not be able to read the branch relation or the branch view. The privilege list may be all to revoke all privileges. So, instead of revoking select, insert separately, you can just say all and revoke all of that. The list of revokee can include public, which means all users lose that privilege, and or those who are granted. If the same privilege is granted twice, now it is possible that a user gets a privilege granted to him or her by two different granting authorities. Then if once is one of them is revoked, the other will still continue to remain. So, every privilege that is granted needs to be explicitly revoked, that is the basic meaning. So, all privileges that depend on the privilege being revoked are also revoked. So, some privilege which is dependent on some other privilege, if you revoke the update privilege, then the select privilege will remain. But if you revoke the select privilege, then if you also had the update privilege, that will certainly get revoked, because if you cannot read, then naturally you cannot change. The SQL also allows you to create certain roles. Roles are kind of like virtual users. So, we all say that we all play certain roles. So, I have an entity as an individual, say I may be a user called PPD, but I have a role as an instructor. I have a role as a, say, the head of the department. I have a role as a chairman of a committee, and so on. So, oftentimes it becomes easier to grant privileges to different roles. You do not really care immediately about who that individual could be, who that particular user could be, who has that privilege. Whoever plays that role gets that privilege. Whoever becomes the director of IIT Kharagpur has the privilege to appoint faculty members. It is of that kind. It does not specifically. So, role is of that kind of a concept. So, you create role. Here we are saying that the role is a role instructor is created, and then you are saying that you grant instructor to Amit, which says that Amit now plays the role of instructor. So, any privilege that the instructor role has, Amit will enjoy that. So, let us see more of this. The privileges can be granted to roles. So, earlier we said it could be public, it could be users, but now we are saying that it could be to roles. So, here this role was created and the privilege is being granted to that, and since Amit plays that role, it will mean that Amit, with this grant select on takes to instructor, Amit will actually get a privilege of select on takes relation. That is the kind of derived structure that roles give you. Roles can be granted to users as well as to other roles. So, roles are becoming like virtual users. So, you can create a role teaching assistant and grant teaching assistant to instructor, which means that if you do that, you are granting this. So, it means that any privilege that teaching assistant will have, the instructor will get those privileges, because you have made an instructor to also play the role teaching assistant. Mind you, instructor itself is a virtual entity. So, if Amit is an instructor by this, then Amit plays this role and this role plays teaching assistant role, and this teaching assistant role has certain privileges. So, naturally through this chain process Amit will get those privileges. So, instructor inherits all privileges of teaching assistant. So, this is what exactly what I was talking of. You can have a chain of roles, create a role dean, new one you have created, then grant instructor to dean, grant dean to Satoshi. So, which means that once you grant dean to instructor, so anybody who plays the dean's role will get all privileges of instructor. Here you are saying that Satoshi is going to play the dean role. So, the Satoshi in terms of chaining gets all the privileges that instructor has. So, once this has been done, then you can have authorization on views as well. So, you have created a view here. So, this is a view created, the geo instructor, the geology instructor, and on that view particularly you have given the privilege to the geo staff. So, a geo staff member would be able to access this view, and if this query is fired by a geo staff member, which I am assuming is a role, then this view will get executed and the results of all instructors in the department geology will be obtained. But what if the geo staff does not have permission on instructor? It does not matter. That is the beauty of the whole thing. The geo staff may not have permission to do select on instructor, but the geo staff has permission to select on geo instructor. So, the geo staff will be able to execute this view, but the geo staff will not be able to do a select on from the instructor database, instructor table. There are several other authorization features. The references privilege to create foreign key. So, we talked about the basic read write data manipulation privileges, but there could be other privileges like whether you can create a foreign key, whether you can transfer of privilege. So, whether you can give one privilege to another. So, whether you can cascade, whether you can restrict and so on. So, transfer of privileges is also privilege. I mean actually you will have to think of this as an authorization. So, actually what we can authorize is also a privilege that needs to be authorized. So, these are the derived privileges that are required. So, in summary, we have learnt about SQL expressions to deal with integrity constraints. We have familiarized with more data types, particularly user defined types and domains, creation of index, and we have discussed about the authorization in SQL. Each one of them, particularly authorization, has a lot more details, but at this intermediate level we just wanted to get a basic idea about authorization to be able to deal with that. So, with this we close our discussion on the intermediate level SQL features. In the next module that we start next week, we will talk about some of the advanced SQL features.